Are you drilling into the table? Nah, I didn't do it. Whoa, 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 whoa. Well, what's this right here? Look at this. You were gonna drill right through the table. All right, we've all seen it, and we may have even done it drilling right into a drill press table. You know those shops that you go into and the drill press vise and the drill press table looks like a block of Swiss cheese. Check out this table right here. This is from a 1951 Walker Turner drill press that I have, and I am restoring this drill press. I'm doing a whole video on it, but today I wanted to show restoring this drill press tabletop here. And you can see it has all these holes. They usually form a smiley face. You know, people are trying to cut off the front of the table. But this is a nice table. This is a production table. You can see the coolant trough all the way around. Now, this is supposed to have no holes in it so that that coolant can run off to the side down here through the pump and come back up. All right, so the process that I'm gonna go through today to repair these holes is to braze these holes. Oxyacetylene, I got some brazing rods here, but first I'm gonna have to clean out all these holes here, get all the dirt, all the junk out of them, get down to clean metal so we get a nice bond of the brazing rod. Here is a closer look at the table, and you can see all of these holes. You can see all the dirt and grime in there. Look, even somebody went after this with a hole saw. Good Lord. I didn't do it.
So I have to enlarge these holes a little bit just to dig out all this junk, get down to clean metal. Then I'm gonna braze these all in, let this sit overnight, and then I'm gonna put this up on the milling machine and I'm gonna face off the whole top. I'm set up outside here because, you know, working with cast iron, this stuff is a black sooty mess. All right, so the first way I'm gonna attack this is with a carbide burr here on the die grinder. I'm gonna try to dig all the dirt and get down to fresh material. All right, now I just have a little Scotch-Brite pad, and these just screw onto the little sander here. And I'm just gonna go over the top surface here, try to hit the edges. All right, the first step in brazing this is that we want to preheat this. So what I have here is I have some rock wool insulation. This is propping up our table. Now I have that on top of a welding blanket, and even under the welding blanket I have another layer of rock wool. Now this is important because not only when we're heating this up is it going to keep the heat in, but I want to let this cool down overnight. So after we're done brazing this, then I can take the welding blanket, wrap this all up, put more rock wool insulation over the top, let this sit overnight, and let it cool very, very slowly. That's important. What we're doing here is when we're heating this up, we're expanding all this metal. So when we heat this up, we want to heat the whole thing up, not just this area right here. This is going to get the most intense heat, but we want to expand this whole thing at the same rate. So it's going to take about 15-20 minutes to heat this up, get it up to temp. Here is the welding rod that I'm using here. Now this is this Vulcan 320, and you can read here, zinc controlled, flux coated, low fuming brazing rod for cast iron, steel, and bearing surfaces. So this is a nice alloy for cast iron. You can see here, melting point 1570, so that's what we're shooting for. I do have a digital thermometer. I can shoot in here. I can tell when I'm coming up to temp, but you can also just tell by looking at it. As soon as this starts getting a nice red color, we're not talking cherry red, but this will get like a nice dull red color. We can kind of tap the rod in there and see if we're ready to roll. All right, so I'm going to spend some time now heating this up. Here is a closer look at this rod. So it is flux covered rod. I also have a can of flux because sometimes you want to dip the rod in there and you want to put the flux where you want to put it. This process of heating up the table took about 25 minutes. It is a good heavy chunk of cast iron here. Has some different thicknesses. You see right there I got up to about 237. Next check here I'm at 350. Then I'm moving up here at around 1,000 degrees, 980 or so. I kept going to about 1,200 degrees, and that kind of tops out that thermometer. So here I'm just getting this to a nice red color, getting ready to bring in some brazing rod. I turned down the oxygen and acetylene on the torch, and I'm just starting to lay some flux down here in the bottom. And I just want to put a base coat across all of these holes. I don't want to fill these totally up right here. I just want to get a base coat down low. But I realized here I had a problem going on with my regulators. The oxygen pressure kept creeping up. It was going way up. I would turn it down and it would go way up again. I knew something was wrong. All right, something was going haywire with these gauges here. So when I was brazing that, I was, I know I was doing it with the cutting torch, and that's not optimal, but my old brazing tip that fit on this guy was all dinged up and it's no good. And at the same time, I kept trying to turn down the oxygen pressure so it wasn't blowing so hard on the braze. It was just blowing it around too much. And something was going haywire. Look at these old gauges. I don't know when these were made, maybe 1920. But something was happening. Even if I would turn down the pressure on the torch and on here, this just kept creeping up and up and up, and the pressure was just kept getting higher and higher, and I'd turn it down and it'd go back up. So I don't know. I guess it's time to retire these. So anyway, I looked on OfferUp, an app I have on my phone, and a guy not too far down the road was selling a brand new set of these Harris regulators and a torch, never used. So I went over there. I picked this up from that guy for $150. So not too bad. It's not a huge torch, but it does have a brazing tip. This torch is still good. It needs a little rebuild. I got to rebuild some things in here, but still a great torch. But this set came with a brazing tip, and this is going to make this job a lot smoother. Even though this is a brand new brazing tip, it's a good idea to go in there and clean this tip out. So what I have right here is a little selection of tip cleaning files. You can see they get real tiny down here, but you find the one that fits in there. So you go through and you find the one that fits nice and snug, and just give this a quick little file in and out. Sometimes it's good to do this when the torch has a little oxygen in it and it blows the chips out. You can also go right across the face of the tip with this little file. It's a little junky file. Better to use a real one. But good idea to clean this out. There might be a little burr in there that can affect the flame. And you want to do this periodically, when you use the torch, so you get a nice clean flame. Now, I went over the top of this just to clean it up, just to get off any of that old flux. I even went over the top of the braze lightly with that carbide burr, just to get down to nice, clean material. These new gauges feel so good, so I'm going to start out, heat the plate back up. I'm going to use that cutting torch tip on this just to heat it back up, then switch over to the brazing tip. So I'm going 35 on the oxygen, and then I like to go 5 on the acetylene. And then when I switch to the brazing tip, I will dial this down a heck of a lot lower for some nice control. That was the problem with the old regulator. Even if I dialed it down, boy, this was just cranking way up. So what a nice new addition here to have some new regulators and feel a little safer too. Alright, this is not as big as my other torch. Ideally you want a rose button to do this, but this will heat this up quicker than the brazing torch. So I'm going to heat this up, then I'll switch to the brazing tip to do the brazing. Alright, you don't need to see me heat this up again, but I did bring in the MAP gas torch to help out. Now the oxyacetylene, that gets around 6,300 degrees Fahrenheit, and the MAP gas gets around 3,600 degrees Fahrenheit. So it is good to bring that in just to speed up this process since I'm doing it for a second time. So starting out here with the braze, there was a couple spots where it was still bare cast iron, so I used this rod with the flux, but then here I switched to a rod that has no flux to go over the top of the existing braze. Alright, I think that's looking pretty good. I know I got a little bit of excess on there. It might not be the most beautiful braze in the world, but I think it's going to work for what I need it to do. Kind of looks like a little chain of islands, like the Hawaiian Islands here. Alright, so I'm just going to heat up the surrounding surface one more time, wrap this up in the blanket and the insulation, and let this cool down. Alright, now these coals will simmer until sunrise. You best go do likewise. Alright, it's 7 hours later. I just want to check the temperature. Let's see what we got here. Still at 150 degrees here 7 hours later. I got this raised up quite a bit, so I'm going to go over this with the flap disc before I bring this in and put it on the milling machine. Let's see if we sweep this table now. It looks like we're around 20 thousandths low here in the back, so we got to bring that up. I do have some 20 thousandths shims, so I'll loosen this up. We'll crank up the back and then we'll check it again. All right, what I'm attempting to do right now is to clamp this lightly, get it dialed in with the dial indicator, get this nice and flat. It's kind of a tricky task. Now, what I don't want to do is clamp it and distort the table, and then after I mill it flat, I let the clamps loose, check it again, and it's got some sprung shape to it, so I'll distort it. What I got here is a can of the Starrett 666 feeler stock here. 4 thousandths thick. This is great to snip off a little piece of this. Can help shim up this table. We're 0 here in the back, 0 here in the front. On the side, we're about 4 under. But over here, we are 4 under as well. 5 under over here.
So 5040 is what we got going on. And everything is clamped pretty loosely. So what I'm going to do is do like a little star pattern clamp down just slightly. Go from here to here, here, here. Try not to put too much pressure. And keep it the same. Here is the first pass over, and you can see we have a low in the middle. It's high all around the edges. I'm kind of limited on my travel, so I'm not able to come off the table with the cutter back here. It's looking really good. This is going to be much flatter than it ever was. Okay, while I'm letting the table cool down, I'm gonna flip these inserts around. So got my little insert Torx tool here. And we're just gonna pop these out, give them a turn. So here's a look at this insert, and you can see the top edge there is a little worn and our bottom edge is nice and fresh. So I'll flip these. And for those interested, these are R390 inserts. There's the number right there. All right, here is a close look at the table here. Looks like I still have to take out about 5 thousandths or so right in this area. So one more pass. I got the new inserts in there. I also let this table cool down. It was hot after doing some cutting on that. I like to let it cool down so it can relax back into its natural shape. All right, I am pretty stoked. I think this worked out great. You can see here, there is one little tiny chip. There was some porosity in that one right there. But other than that, this all looks pretty good. There's a little chatter here, but I'm not worried about that. And all these little lines right here, you can barely feel any difference there. So I'm pretty happy how this turned out. I think it looks great, and it's amazing how far this was off. There was a big dip in the center. I know I put heat on this and that type of thing, but when I milled this off, you know, the surrounding edges were a lot higher than the middle. So this is a lot more flat than what it was, and I think it looks great. This is going to be
a nice fix here for this old Walker Turner, bringing it back to life.
All right, take a look at this new shiny table. Doesn't that look deluxe? Remember what this thing looked like? Remember the hole saw marks and all the holes in this full of grime and grease and dust? This is looking dynamite. Now I can get back to work on this Walker Turner drill press restoration. You know, I was just about to paint this up and I was like, you know, I should take the time right now while I have it apart. I can heat this up, mill this off, and now I can put some paint on this and reassemble that drill press. Now, I know I could have done this with a fly cutter. I don't have a really nice fly cutter. I was looking at those Suburban tool fly cutters. Those look really good. That might have been a great tool for doing this, but I am really happy with the results with that face mill. I think this just came out just perfect. Looking good. You know, not perfect, but really good for what I'm using it for. All right, I hope you guys enjoyed this video. I had a lot of fun making it, and be sure to stay tuned for the next video coming out about this Walker Turner drill press restoration. I restore this 1951 Walker Turner drill press, and I also give some history about the whole company. I think it's a really fun video. I think you guys are really gonna like it. Also coming up soon is the Jacobs Chuck video. I got that dialed in, working on that as well. All right, I hope you guys are great, and I'll see y'all soon. Watch your top knot.